In part 1, we saw how to use a transformation stack to make it easy to draw a mobile. We saw that the function push matrix pushes a new coordinate system on top of the stack, and pop matrix throws away the top of the stack and returns the coordinate system to what is then left on top. There's one other command which is really just a utility. It's called reset matrix. All this does is it takes the coordinate system on the top of the stack and puts it in the default location. It puts that coordinate system in the upper left, x pointed to the right, y pointed down, both of them 1 pixel big. This is not used a lot, but every now and then after you do a lot of transformations, you might say to yourself, man, I just wish I could get the thing back up into the corner in the starting location again. If you want to do that, reset matrix is your friend. So now let's look at using push and pop to draw the mobile. In the code, I've taken out all the numbers that tell us how much to translate or rotate or where the lines begin and end because I don't want them to distract us. I just want to focus on the basic idea. So let's run through this very quickly. Of course, we've already built up this frame. I just want to show you how push matrix and pop matrix do their job. So let's begin with a translate call. Great, we translate into the middle of the screen. Now we know to draw the first line going down. Now we move the coordinate system down. And we draw the big dot that connects the two bars. We rotate the coordinate system a little bit, and now we reach our first push matrix. Great, now we make a copy that goes on top of the stack, and that becomes the active coordinate system. Now we're ready to keep drawing, and in the next line you'll see I indented. There's no really hard rule for this, but I like to indent these things so I can just tell visually when I write the code, oh, I just pushed the matrix. That tells me eventually I'm going to want to pop it. So the indenting is just a visual cue to help me remember that every push has to eventually be followed up by a pop. Okay, let's draw the line that constitutes the top of the bar. We'll move off to the left-hand edge. We'll draw the line that goes down to hold the next piece of the mobile, translate down to the bottom of that, and we'll draw the dot that connects the two pieces together. We'll rotate a little bit so that the bar is passing through the x-axis, and now we have our next push matrix. That says make a copy of the coordinate system. So there we go, we take the snapshot, that goes on the top of the stack, and it becomes active. Now we're going to draw the line at the top of this little subassembly, and notice I indented again. I've pushed the matrix twice, so I'm indenting twice. I draw the line, I translate off to the left-hand edge of the line, and now we do a bunch of other stuff. We translate, and we scale, and we get the coordinate system into position to draw the duck. So I'm going to skip that, and now I'm going to draw the duck. Now I'm ready to go back to the first knot where I did my first push matrix. So now I call pop matrix. And notice I unindent there. And that's, again, just my convention. So visually I can see, oh, all the stuff that happened between push and pop got indented one tab stop. So okay, if I pop the matrix, we know what happens. We simply throw away the topmost element on the stack, and the transformation system goes back to where it was. Just for demonstration's sake, I'm going to push the matrix again from here. So I'm going to call push matrix again. We stick a new copy on top of the stack. That becomes active. Great. Now we start working our way forward again. We indent one level because we just pushed the matrix again. I translate to the right. I do all the other stuff to get into position to draw the bear. And now I draw the bear. Now I want to go back to my first save point. So I pop the matrix, that throws away the top one, and I go back to the top of the first subassembly, and now I pop again. That throws away that version, and we go all the way back to the top of the mobile. Now I translate to the right, and I continue on to draw the elephant, and I'm done with the picture. So here's everything you need to know about controlling transformations. In the upper left, we have push matrix. Take a copy of the coordinate system, put it on top of the stack, and now that's the active one. Its complement is pop matrix. That says throw away the top of the stack, and now the topmost element that remains becomes the active transformation. Finally, in the bottom, we have the convenience routine called reset matrix, which just puts the coordinate system back into its default location, orientation, and size. One thing to keep in mind is every push needs to ultimately be followed by a pop. Now you can interleave these things any way you want. You can push 3 times, pop once, push 2 more times, pop 3 times. It doesn't matter how you mix them up, but every push eventually gets followed by a pop. If you try to pop when there's only one thing left on the stack, processing will give you an error. That's because you always need at least one coordinate system around, so processing knows where to draw things. So remember, if you're looking at a piece of processing code, every time you see a call to pop matrix, you know somewhere earlier in the program there was a call to push matrix. This might seem like a kind of a weird way to set and restore undo points, but almost every graphics language in the world does it this way because people have found over the years that managing a stack with push and pop is really a wonderful way of doing it. You only need to save the coordinate systems when you're somewhere that you want to save, and then you can use pop to return to them. Once you get used to this, it becomes totally second nature. In the next video, I'll show you a number of examples of using push and pop to create images and animations.